Hi, and welcome to lesson presentation for Chapter 8, Algebraic Reasoning, Graphing, and Connections with Geometry. So, here we go. First, we're going on a road trip. Okay, so we're going to go to Mardi Gras, and we decide, oh, let's get in the car and go, right? Fun, yes. So, what we're looking at here is our y-axis, which is our vertical axis, and that means up and down. It shows our gas gauge. How much gas do we have in our car? Then on our x-axis, which is our horizontal axis, we're looking at our distance that we've traveled. So we jump in our car, and we didn't look at our gas before we started moving, but we didn't have a full tank. So we get in our car and we travel, and what you will notice, the further we travel in distance, the less gas we have in our car. Go figure. Well, we get down to this point and we decide to stop and get some fuel. Well, the car's turned off. We're not moving, correct? But we're putting gas in our car. So here, you're going to see our gas level rise. So our Y value gets greater, but we're not moving to the right. Then, once we start our car and get moving again, the further we go, the less gas we have in our car. And that's what this graph is about. Then we're going to look at our elevator ride. So on our y-axis, we're looking at the floors in our building. And our x-axis, we're going to look at the time we spent on each floor. We've all gotten in that elevator and some kid done pushed every button. So now you have to sit and wait for the doors to open and close on every single floor. Okay, so here we start off at the ground floor and we go up vertically, and then we wait for the doors to open and close, up vertically, and we open and close. And that's exactly what it's showing going through each floor of our elevator ride to the 5th floor. Next, we are looking at a bouncing ball. So here we have a ball falling off of a table. So that's why our ball starts off kind of high, right? Well, every time, and our y-axis is our height, every time our ball hits the floor, what's automatically going to happen? It's going to bounce. Well, what we notice in this graph, with each time, the height gets less, right? So this graph depicts that with each bounce, the height is less and less. Now, we're looking at this graph. They were wanting us to show the length of a shadow at different times during the day on a flagpole. Now, for us, it's easier to relate to if I stood outside all day long and watched my shadow, what would happen to my own shadow? Well, in the morning, the sun's coming from the east. So what you're going to see is a long shadow going out. Well, then as the sun gets higher in the sky, our shadow shortens. Then when it's directly over us, we virtually have no shadow or none at all. Then as the sun starts setting in the west or going towards the west, our shadow gradually gets longer. So here, that's what we see. We have a long shadow, which the length of the shadow is on our y-axis, and the time of the day is on our x-axis. And then as it gets later in the day, well, as we get closer to noon, we have less of a shadow. And then after we get past noon, our shadow gets longer again. And you will notice this U shape or the curve in our graph, that is a parabola. Okay, next we have 2 machines. We're going to think this like 2 machines going on, and one machine is dependent on the other machine. So in this, we're going to start with our table, and we're given a problem, and it says g of f of x when x is equal to 0, 1, 2, or 3. Do not get overwhelmed. We're going to start with the simple things. I want you to draw a table, and on that table, we're going to have 3 columns. We're going to have x, then we're going to have f of x is equal to 3x. Then in our last column, we're going to write g of f of x is equal to x plus 8. Now, forget about the second 2 columns. We're going to the first column. And in that x column, we know that it says x is equal to some definite numbers, right? It has definite values. One time, x is going to be 0, and then go to the beneath it, and we're going to have x is equal to 1. Then underneath that, we have x is equal to 2, and x is equal to 3. So x has all these values. Now, we're going to move to the middle column. Our second column, we're saying f of x is equal to 3x. When we say f of x, that is the same as saying y equals 3x, okay? So here, what we're doing is saying when x is equal to, and whatever this x value is, so when x is equal to 0, so we put that 0 right there, then y is equal to 3 times x, which is 0. So we're going to replace our x values for x in our equation. So 3 times 0, 3 times 1, 3 times 2, and 3 times 3. Now, that's our first machine. So our first machine got us some y values. Well, our second machine, we can't get that y value until we know the answer to the first y value. So here we're saying g of f of x is equal to x plus 8. So what this is telling us, whatever f of x was or is what we're putting in place of the x. That is now our x value. So in our second column, the answer that is our y value becomes the x value for the third column. So here we're going to say g of f of x, or you could put y is equal to, and we're going to use the values that are in the second column. So 0 plus 8, 3 plus 8, 6 plus 8, 9 plus 8. And that will give your column our values, our y values. Then we have to plot this on our coordinate plane. When we're looking at our coordinate plane, so for x and y, we automatically know, right? 0, 0, 1, 3, 2, 6, 3, 9. When we get to that third column, well, you automatically, a lot of you are going to think, oh, I need to put that x, 0, 8. And that is exactly what we do. And then we're going to put 1, 11, and 2, 14, and 3, 17. So where I was going there, when we look on our actual graph, you're going to see that we could have come out with these points without looking overwhelmed at these big equations, because here it's 0 plus 8 is 8, and where we have 3 for 1, 3, you have to add 8, so we have 1, 11, and it continues. Okay, so on to part 3. And here we're given points and you have to graph them. We plot the 2 points that are given, and then we connect them with a line segment. And for these problems, we have to figure out the slope of the segment we're given. And this segment goes upwards and to the right, so we know there's going to be a positive slope. So to find the slope, we need to know the change of y over the change of x, or it's the same as y2 minus y1, that's how we get the change, over x2 minus x1, which is the change. So where do we get the x and the y values? Well, remember, x is our first number in a point, and y is the second number in a point. So we're looking at y2, which is 5 here, and y1, which is 1. And then x2 minus x1. So here we know our slope is 2. And we do the same thing for this one. We're given points. Now on this one, we notice that our line is vertical. And my brain automatically says, there's no rise over run, right? There's no run. It's not running anywhere. So when we do write it out like we would normally do, the change of y over the change of x, well, what we notice is our change of y is negative 16 and our change of x is 0. We can't have 0 as a denominator. So that means our slope is undefined. So anytime you have an undefined slope, it is a vertical line. And I guess you could say it the other way. Any vertical line is an undefined slope. Here we have points for u and v. And once again, we draw our line segment and rise over run, or we can look at it as change of y over change of x. And we have, sorry, I went too fast, 3 will be our answer. Here, we're exploring parabolas. Yay! Okay, so we're given 3 functions. And I created a table, and in my first column, I always put x, the values that I want to use for x. Then our second section, we are given the equation x squared, y equals x squared, or f of x. G of x is equal to x squared plus 7, and g of x is equal to x squared minus 7. I put this in Excel and let it roll. We can do simply what we did in previous problems, where you literally just take the value of x and plug it in wherever you see x on here. So not f of x, just x. So here we have f of x is equal to x squared. So that would be negative 10 squared is going to give you 100. Negative 9 squared is 81. And it goes on. Then in the third column, you're going to have g of x is equal to x squared plus 7. So you're going to do the same thing. Plug negative 10 into where x is, negative 10 squared plus 7. And there you go. The last column, instead of adding 7, we're taking away 7. So we complete our table. Then we graph this. And once again, you see big smiley faces. And yes, I'm a Mardi Gras girl. That's why you see my colors. So what we can see is our f of x is equal to x squared. That's in purple. So you have this nice, big, wide parabola. Then when we get to g of x, that's in the gold color. It's a little narrower, and that one is x squared plus 7. And then when we get to the green, it's x squared minus 7. So then we can start showing the relationship that the curve of our parabola is now narrower or wider as the constants are added and subtracted, right? So when we have constants added to our x squared, it gets narrower than when we just have x squared, but depending if you're adding or subtracting it is also changing that. Then we get to 5a, and with this one, we're given y is equal to negative 3/4 x plus 5, and we're given the point 6, negative 1. Now, with this one, we're trying to determine, oh, wow, I'm getting tongue-tied. The perpendicular line, right? The equation of the perpendicular line. So we know our original slope is negative 3/4 because whatever is before the x is our slope. So our original slope is negative 3/4. So we use the equation or the formula y minus y1 is equal to the slope times x minus x1. This time, when we're looking for our perpendicular line, we use the opposite reciprocal. So that means since the first one was negative, we're using the opposite. It's positive. Then the reciprocal of 3/4 is 4/3. So we're going to take our original point and plug in our y1 and our x1. Now here, we need to distribute that 4/3. And we distributed on y minus -1, that's the same as having y plus 1, and it's equal to 4/3 x minus 24/3, and 24/3 is the same as 8, right? So we have y plus 1 equals 4/3 x minus 8, and then here we're trying to get y by itself. So anything you do to the left, you have to do to the right. To get y by itself, we have to subtract 1. So we have to subtract 1 on the right. -8 minus 1 is -9. And make sure you pay attention to that when you're working your problem. So y is equal to 4/3 x minus 9. So we have our table. And once again, we have x, our values of x. Then we have our first linear equation and our second linear equation. So these two lines will run perpendicular to each other. So we're given the perpendicular point of R, and here we go. And that's our perpendicular lines. Next, we are given, for 5b, 2y plus 9x minus 5 is equal to 0. And the point S is at 0, 3. First off, we know that 2y plus 9x minus 5 is not a linear equation. So we know we need to fix this right now. So we want that in the form of y equals mx plus b. So let's rework that. So once again, we want to get y by itself on the left. So we're going to work this problem till we get there. 2y is equal to -9x plus 5. And then we have to divide that by 2. So remember, we have to divide each thing by 2. So when we divide 2y by 2, that's just going to give us y. So y equals -9x divided by 2 plus 5 divided by 2. So that gives us the slope of our original line, which is -9 over 2. Then from there, now we're looking for the perpendicular line that runs through point 0, 3. And we're going to use the y minus y1 equals slope times x minus x1 with the opposite reciprocal of 2, 9. And we work through that. Y minus 3 equals 2/9 x minus 0. Remember, when you multiply anything times 0, you get 0. So when we distributed that 2/9, we still got -0. Then whatever we do to the left, we have to do to the right. So to get y by itself, we add 3. Y equals 2/9 x plus 3 is our equation. So we're going to put that on a table. And then we graph that. And there is our perpendicular lines. Okay, so here we're looking for, it's the equation of tangent lines. And in this instance, we have a radius of 9 at, well, we're looking for the tangent line of a circle when the radius is 9 and the point is at 0, -9. The center of the circle is the origin. So we have, first we're going to take out our coordinate plane and we're going to plot these points. So we start off with 0, -9. So we have 0, -9. Now, with the radius of 9, we know from the center, from that 0, 0, it goes out 9 in all directions. So from here, we know we come down. That's our original, down 9. We went to the right 9, and we went up 9, and we went to the left 9. So when we write that in our table, our X column is first, and we plot each of these points. Then we plot each of the Y's, and make sure you write them in the table correctly. So we can just look at our points, -9, 0, 0, 9, 9, 0, and 0, -9. Then we're going to put in our circle. So there's our circle, and you'll notice that 0, 0 is directly in the center. And then we're going to write our draw a tangent line. Now, our tangent, when a line is tangent, it's skimming just the surface of that point, right? That point is on the very edge of that circle. So that line's just skimming the bottom of our circle. So first we look at the slope of our line. A horizontal line always, always, always has a 0 slope. We're going to use our same formula, and we're going to use 0 as our slope to figure out our linear equation. So it's y equals 0x minus 9, or you can just say y equals -9, correct? Because 0 times x is 0. So y equals -9, which means all these points or -9, no matter what. So when we look at our tangent line here, which we can tell from the diagram, but this shows us, you know, on a formula basis, that no matter what our x value is, it can be -1,000, our y value is going to be -9. You know, on the positive side, if x is 100, the value of y is going to be -9. So now it says for port B, we're going to look at the radius of 9 at 0, +9, and we want to see the tangent line there. Well, it's pretty much exactly the same, right? So we already know, but instead of plugging in a -9 like we did at the top, we're going to plug in a +9. So it's going to be y minus 9 is equal to 0. So then you're going to have to add 9 to cancel out. So y can be by itself on the left, which is going to give you a +9 on the right. So for part B, our y is always equal to 9. So there we go. That's the tangent line for port B. Now, when we look at this graph, what is the first thing that is like eye-popping in your face? What do I notice? Both lines run parallel, right? So whenever you're looking at a tangent line of two tangent lines of the same circle that are on a particular axis, right? So if it's, I'm trying to think, I think I just misworded, but when we look at it here, when it's 0, -9 and 0, +9, they're going to be parallel. If we would have worked this problem with trying to figure out the tangent line of 9, 0, and then the tangent line of -9, 0, those two lines would have been parallel. So, it's been great. See you next week.